Hi everyone, in this video we are going to discuss carbohydrates. So carbohydrates are basically your sugars and your starches. And so what we're going to do is talk about the differences between the two and the different words that we use to actually differentiate between your sugar and your starch. So the first thing I want to do though is start off with a definition of a carbohydrate. So a carbohydrate. So it's exactly like what it sounds like. It is a molecule or molecules that only contain carbon, hydrogen, and oxygen. So the carbo is your carbon component, and your hydrate is your water component, so it's H2O. So the only thing that exists in your carbohydrates are your carbons, your hydrogens, and oxygens. But what's really, really neat is that in this molecule or molecules, whatever we're discussing, the hydrogen-oxygen ratio is always going to be 2-to-1 because it's always a water component. So keep that in the back of your mind that it always has to be a 2-to-1 ratio for a carbohydrate. So now, what are your carbohydrates? We already identified them. They're your sugars and your starches. Okay, and so we use about 3 different words to classify the differences between a sugar and a starch. So the first word we want to talk about is called a monosaccharide. Okay, a monosaccharide, which is essentially mono meaning one, or in this case we call them single, and then saccharide is usually the word sugar. Usually we say that. So a single sugar. And so now our classic examples of this are fructose and glucose, and I'll show you the molecular formula for these in just a second, but I want to get through the definitions first. So monosaccharide meaning mono, one, saccharide, sugar, so single sugar. So then, as expected, a disaccharide would be a double sugar. Okay, and our classic example of this one is sucrose. And then the last example is your polysaccharide. So poly we've talked about before, that usually indicates some kind of polymer or a large molecule. And a polysaccharide is essentially the polymers that are comprised of thousands. Okay, thousands. We're not talking about 1, 2, 3, thousands of monosaccharide units. Okay, so just if you have any context with polymers at all, polymers meaning poly, many species put together, and it's always put together of monomers, so monomers meaning the single unit. So sometimes you'll hear polysaccharide described as that. It's a polymer that's comprised of a lot of different monomers, meaning the monosaccharide unit. So just so you have some context if you ever hear these words outside of our course. So now the big thing for the polysaccharide, our big examples I should say, are your starches. Okay, and a lot of times people want to put cellulose in here and glycogen. And we're going to talk about all of these in the future. But the first thing I want to do is just show you a very simple reaction of how we go from a monosaccharide to a disaccharide. And this is important. What this is called is a condensation reaction. And hopefully after you see this reaction, you're going to start to kind of put some pieces together. So when we talk about lipids or carbohydrates, all of these reactions are very similar because they all occur inside the human body. So let's talk about how we can go from glucose, so C6H12O6, so we said this is our glucose, and we want to create sucrose. And in the process of this, we eliminate one water molecule. So now in order to balance this properly, I put a 2 in front of my glucose. It's a 1 coefficient in front of our sucrose. We don't really write that. And then 1 for water. So my question for you is, what must be the molecular formula of sucrose in order to balance this equation properly? Remember, there's a 1 coefficient in front of the sucrose. Go. All right, did you get an answer? Hopefully you did, but if you didn't, that's okay. To be completely honest, though, this is a skill you should have mastered by now. So if this is something you've struggled with, take a second and go back through and practice balancing equations because we need to make sure you have this so that we can move forward, all right? So now, the first thing I would do is identify that sucrose is a disaccharide, so we know for sure it's a carbohydrate. So that means that it has to have carbon, hydrogen, and oxygen in its chemical formula, okay? That's it, though. It can't have anything else. No palladium, no arsenic. It's just carbon, hydrogen, and oxygen. So now all we do, since we know that the coefficient is 1 for sucrose, all we do is we try to balance our reactant side and our product side. So on our reactant side, we know we have 6 carbons, but there's per molecule of glucose, but there's 2 molecules, so 6 times 2 is 12. So we have 12 carbon atoms on our product side. Look back at our reactant side for our hydrogens. We have 12 hydrogen atoms in glucose, but 2 glucose molecules. So 2 times 12 gives me 24, so we need 24 on my product side. 2 of my hydrogens are already accounted for in water, so 24 minus 2 gives me 22 hydrogens in sucrose. The last thing you could do is balance your oxygens. So we go back to our reactant side. We have 6 oxygen atoms per glucose molecule, but 2 molecules overall. So 2 times 6 gives us 12. But we see in water that there's 1 oxygen atom, so we have 12 minus 1, and our chemical formula for sucrose is definitely C12H22O11, okay? So now hopefully this reaction is kind of familiar. It seems like something you've seen before. And so what I need you to start doing is being able to identify condensation reactions. So if you recall, when we made our triglycerides, we said we took 3 fatty acids and treated them with 1 glycerol molecule. And then what we did is we created 1 triglyceride, eliminating 3 waters. So essentially in one reaction we have 3 mini condensation reactions occurring. So it's very, very prominent, and it definitely occurs a lot inside the human body. So this is something you need to know, absolutely. All right, so now what I want to do is move on a little bit and talk about 2 different processes. So the first thing I want to do is talk about breaking down starch into glucose. So that's the first process, and then we're going to compare that to breaking down cellulose into glucose. And we're just going to do this very topically, and so we're not going to dive too deep into it. The first thing we want to figure out is that your starch is going to be your rice. These are your potatoes. These could even be spaghetti or tortillas. They are things that the human body can eat. Okay, so the human body can easily ingest a starch and break it down. So remember, your starch is your polysaccharide. It's a lot of different monosaccharide units. And so you can break that down into glucose, which is just the singular monosaccharide. So the human body actually has enzymes, which we know are basically catalysts, that can just break down these starches into glucose. So that's why we eat potatoes, we eat spaghetti, we eat tortillas. We can physically handle this. However, the human body cannot break down cellulose, which is trees, right? We know this. Instinctively, we know this. If I asked you, would you rather eat a potato or a tree? You would say, I'd much rather eat a potato, because our body does not have an enzyme that can break this down. So humans cannot eat cellulose. It's not going to go over well in the human body. Don't do it. However, things like sheep or goats or termites, they all have some kind of bacteria inside of their stomach that allows for them to actually break apart cellulose, this polysaccharide, into glucose, your monosaccharide. So it's a very, very important process, but it's something we need to realize now as human beings and scientists here, that our body can eat starches, but we cannot eat cellulose because we cannot break down cellulose. The last thing I want to talk about is something called glycogen. So let's write this out. Glycogen, I mentioned it earlier. It is definitely a polysaccharide. So glycogen is just a polymer that is created from excess glucose in the human body. Okay? So what happens, the human body sees an excess of glucose, says we don't need all this, so it basically converts it into a polymer that we call glycogen. But now here is the important factor. It is used as an emergency fuel source. So what happens is our body will take glycogen, okay? So it takes, well, I should say it takes glucose, it converts it into glycogen because we can very, very easily break it back down into glucose. Okay, so we have excess glucose in our system, we create the polymer glycogen, and then we store our glycogen in muscles and our liver. So it's very, very easily accessed by the human body whenever we're in an emergency situation. So if you start to get lightheaded or something like that, your body is going to instantly kick in and say, we need another fuel source, and it uses the glycogen, and very, very quickly it breaks it down from glycogen to glucose. And so we just keep that in our muscles and liver, which is really kind of neat. All right, so that's all we have for this video here, but I'm going to leave you with a simple exercise. I've given you all this information, so if you've been taking good notes, this will be really easy for you. But what I need you to do is identify each of these following items as a mono, di, or polysaccharide, okay? So I want you to identify glucose, sucrose, starch, cellulose, and glycogen. Okay? I want to know if they're a mono, di, or polysaccharide. Go. All right, did you get an answer? Hopefully you did, because I just gave you every single piece of information needed to do this. So glucose is definitely a monosaccharide. Sucrose is definitely a disaccharide. You take 2 glucose molecules and you create sucrose, eliminating water in a condensation reaction. But then starch, cellulose, and glycogen are all polysaccharides, okay? Every single one of them. Our body cannot break apart cellulose. We can't do it. We can easily break apart starches, and we can definitely break apart glycogen because we use that as an emergency fuel source. Memorize that. Go.